Hey, good afternoon, people. Today I'm going to talk about photons. In neutron decay cosmology, the postulate is, and the math bears this out, at least fundamentally, that a mass unit that both a proton and neutron have makes sense to be essentially a photon of frequency 2 pi Planck length wrapped around itself like that. So its propagation is rotational rather than outward. Now that derives an angular momentum, boop boop, right? V squared, which is c squared in this case. Okay, and you see where this is going. Mass is equal to the energy that is spread over this sphere spinning at c, giving angular momentum, spherical angular momentum of one mass unit. So yes, so that's a part of neutron decay cosmology. It's treating it like there's this fluid and this is what happens. You make sort of a droplet of it when you excite it too much. Okay, but we're going to see how this naturally evolves from just photons. So let's take a photon and we're going to make, here's a photon. We're going to describe this is, this is the wavelength. Boop, one photon, and there's the positive part and there's the negative part. Okay, so let's just imagine now this is one photon. I know it's up and down, it's just convenient for me right now. Anyways, but this is like one wavelength. This is, I don't know, what's that, in the radio band or something like that? That's got a 10-inch or 20-inch wavelength. Said photon has energy E, right? And now let's just look at this part, this sticky out part, and how much it is, because, let's consider this the angular momentum of this photon. And now we're going to make a photon that's half that wavelength. Right? So now it has this much angular momentum. And now we're going to make one twice that wavelength. Okay, a little uneven. But right, because this area, this is the quantum of energy. So this has to be one quantum of energy. So this has to be one quantum of energy. And notice how that as you up the frequency, the wavelength gets shorter, the further you have to travel. This is the voltage, of course, this is the energy. This is a very high energy, right? Photon here, because it has a very short wavelength compared to this one, and therefore that much higher voltage. But see how this angular part increases. Then all of a sudden you hit limit, okay, of something. It's a very high frequency, obviously, but you hit limit, and then all of a sudden there's like a severing, and now you have this photon loses itself and gets trapped. Never actually makes it out of the atom because the angular momentum wrapped it around itself, and now it's a flow rather than being sort of like an oscillation in a membrane, a spherical membrane in all dimensions at the same time. But still, like, rather than being like a jiggle, which is what a photon is, that jiggle separates, cracks, and now you have a singularity. You have a separation of this. This is a little spinning droplet in the space, a mass unit. Okay, and because it's got mass, it curves space. Okay, this is getting a little messy. That's mass, curves space. This is positive charge because it's concentrated. This is negative charge because it's been stretched. Divergence, convergence. Boom. Hydrogen atom. That's what happens as soon as one of your neutrons decays. One of the photons decays. One part of the charge component goes here, one goes there. Now we have a flow. But see how that evolution makes so much sense. The wavelength just gets so short. And I'm going to post, it was a question on physics stacks. But photon and yes, evolving into mass because of angular momentum. It just makes sense.